Welcome to Data Engineers Lunch, number 101. Don't forget to like and subscribe, as well as turn on the notification bell so that you can get notified every time we post a video or go live. We are close to 3,000 subscribers. We're thinking about doing something exciting when we get there. Today, we will be covering CICD for data pipelines with our speaker, Will Angel. The co-organizers for this event are Rahul and myself. If you are interested in being a co-organizer and want to help get speakers by reaching out to people in the data engineering community around the world, drop me an email or email the marketing email below. If you yourself want to give a talk, a data engineers lunch, or one of our sister lunches, Cassandra.Lunch, please feel free to reach out to me or this marketing email. We are part of a larger community called Data Community DC, which believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome, and we expect respect to be given to all. Data Community DC is actually made up of a lot of different groups, generally centered around data. And you can find out more about all the various groups and events at datacommunitydc.org. I know our speaker, Will, here can give us some exciting context about Data Community DC. What do we cover at Data Engineers Lunch? We cover all things data, ingest, transformation, loading on a variety of data platforms and databases. If there is anyone new you'd like to say hi, what brought you here, please drop a note in the YouTube chat. And if you're watching on YouTube, don't forget to like and subscribe, as well as turn on the notification bell so that you can get notified when we post a video or go live like we have today. If you have a question, our group rules, please ask your question. I'll be monitoring the chat, and Will mention that he will as well. Please be polite and courteous to others, and share what you know. Here at Anant, we design, build, and manage global real-time data and analytics platforms surrounding Cassandra, Spark, and Kafka. So data engineering is our bread and butter. Thanks to our sponsors, including DataStax, thanks to George Washington University, and our other organizational sponsors. George Washington provides venue space when we have in-person events. If anyone has job offers, is looking for a job, please drop a link in the YouTube chat. If anyone has meetups, hackathons, classes, or conferences that you would like to promote, feel free to drop those links as well. We currently host Data Engineers Lunch Mondays at noon Eastern. But if you want to see these lunches happen at a different time, please reach out to us at the marketing email and let us know. We're considering hosting some lunches occasionally at a different time. And with the power of the internet, of course, we can do that. All of our videos are available on YouTube, starting with Cassandra Lunch number 10. And you can check out our most recent public runbook. This is using Terraform and Ansible to install Cassandra on AWS and Azure. I will post the link in the YouTube chat. So everybody, let's give Will a great intro. Will, thank you so much for being here, and we're really looking forward to what you have to share.
All right. Thank you, Nick. Appreciate the introduction, and I'm excited for the talk. So let me go ahead and share my screen. Hopefully everyone can see that all right.
Yeah, it's coming through great.
Excellent. Cool. Well, hello, everyone. I'm Will Angel, and I'm going to be talking about CICD for data pipelines. If you have questions, feel free to put them into the chat. I may address them either during the presentation or a little bit later at the end when I've got some time reserved for questions. So what are we going to be talking about today? CICD for data pipelines. So we're going to be doing an overview of continuous integration and continuous deployment. We're going to be talking about specific practices for CICD, and then we'll be talking about CICD for data pipelines. That's the real exciting part. And then I'll talk about some of the ways in which CICD practices don't always apply or don't apply well to data pipelines, because there are some nuances to data that make it a different domain from application development. So with that, let's jump into it. What is CICD? So CICD is a set of practices, continuous integration, continuous delivery, that are used to help you deliver software better and faster. And this is sort of part of DevOps as a whole. One thing to note is that I will be using continuous delivery and continuous deployment somewhat interchangeably. And I will go into the details about how they're distinct, but from a sort of conceptual perspective, CI/CD, it may mean continuous delivery, it may mean continuous deployment, but the distinction between those two is relatively small as far as additional steps go. So continuous integration is when your code is automatically built, tested, and merged into source control. Continuous delivery is when your code base is always ready for deployment. And then continuous deployment is when that deployment happens automatically and is triggered on successful code changes. So I'll go into more detail on all of these later on, but this is sort of the concept in a nutshell. So why? What does this get us? So CI/CD tooling and processes are there to increase the quality of the software we build, put us in a position to make faster changes, and really improve developer productivity and satisfaction. So the goal is to make better software faster and with less stress, because there's a huge amount of pain and suffering that you can get into without adopting some of these smoother processes. So a lot of you have probably seen this classic DevOps infinity figure eight. And the thing that I want to note here is for each of these steps in the sort of DevOps software development lifecycle, you'll note you've got building, testing, releasing, deploying. That right there is half of the 8 items here. And all of those, if you're doing CI/CD, those are basically all automatic. So you can basically reduce the cycle time and just the number of things that you're doing with CI/CD. So you can go from like 8 steps to basically 4.5. So there's an opportunity to make your feedback cycles a lot tighter, which results in better delivery and less pain. CI/CD was originally really created in the early 2000s as a response to a lot of the processes of the day, because again, continuous integration is an alternative to discrete software integration. Likewise, continuous delivery is an alternative to manual delivery and deployment. Source code conflicts are never much fun at all. And the more time you have code be separate, the more larger the different number of changes and the longer they're apart, the greater the chances that you'll have huge issues when you try and integrate it back together and then turn into something that works. Likewise, dependency management in trying to wrangle everything into a deployable build, if you don't have automation and sort of good processes around that, you really set yourself up for a lot of pain, and that can take time, which from an organizational perspective becomes very expensive. I've heard stories from the dark old ages, which were a little bit before my time, but apparently at some larger enterprise companies, for a monthly release, they would do one release and deployment a month. Apparently the integration period could easily be a week or a week and a half or more. So at that point, that's a quarter to a third of your development time goes into just making sure everything fits together at the end and can actually be deployed. So for the most part, things are generally a lot better now as a software industry, but there are a lot of places where it's still possible to do things manually and just get a lot of friction and give yourself the room for defects. So we don't like that. Like I said, the good news is you're probably already doing a lot of this. So if you're using a hosted Git provider like GitHub or GitLab, even Bitbucket, all those, if you have that and you have tests that run on a pull request or a merge request, that's continuous integration. I mean, you also have to, be doing that continuously. So it's still possible if you have long-lived branches to set yourself back up for merge conflicts, but there's a good chance that you're already doing the continuous integration part and continuous deployment to an extent. So if you have deployment pipelines that you can trigger easily that are consistently work, then you're doing CI/CD, which is a pretty decent way to be building software. So let's talk about some specific practices. For continuous integration, you're going to want to check your code in and integrate it often. And this gives you a couple of benefits, most of which are downstream of identifying any conflicts early in the process so that you can have that communication and reduce wasted time. So if you're working on some software and another developer needs to make a change to that so that they can make some other change, if you're merging your software in every day or multiple times a day, just all the time, you'll realize that conflict within a couple of business hours. And that way you don't, a week down the road at the end of the sprint, you don't have an issue where someone's branch conflicts with your branch and then you're late because things won't fit together. So forcing that communication allows for conflicts to be resolved earlier, more upstream when the cost of changing them is lower. So that saves time overall. Likewise, by having this requirement to merge your code often, if you don't have automated tests, that's going to take a lot of extra work for manual testing. I mean, you could just not test, but don't do that. Test your software. But this is a strong incentive to invest in automated tests and fast builds if you have a build process. So that then helps you build a culture of testing, which leads to higher quality. So for these tests, when you change software, there's a risk that you'll break something. And if the code is broken, then you can't deploy it and you can't ship it if you need to make updates. If you have tests, then that protects you from making obvious issues and you can verify that the software works correctly. One of the benefits there is having a good set of tests actually allows you to make your delivery and development more predictable, which from a business perspective is usually quite desirable. So let's talk about continuous delivery. Being able to deploy your software on demand is a good thing. If you have to fix a bunch of code conflicts before you can deploy, that makes the deployment process slower and it's harder to respond to any urgent issues that come up. I mean, it's sort of the equivalent of if you have a car, if you have to jumpstart your car before you drive it, that adds time, it adds uncertainty, it makes the experience a lot more stressful. So being able to have confidence that you can always deploy and deliver your software is very valuable. So for deployment, you're going to want a way to programmatically deploy your code. And this could be as simple as like having a bash script and just doing things programmatically, but in a fairly low-tech way, or going for full GitOps automation, which we'll talk about in a second. And really the goal here is to increase the confidence that things will work. Because you might say automated deployment, well, that sounds scary. What if we automatically deploy broken change? If you know that your code is going to be automatically deployed, ideally, you as an individual and as a team will build the safety into the process so that code isn't getting into your mainline branch unless it's ready to go. So having that continuous deployment or sort of on-demand deploys is very valuable. So a note on GitOps. GitOps is the idea where everything that you need to deploy your software, so the code, the infrastructure as code, sort of just about everything, is in version control, Git, hence the name GitOps, and that it gets deployed automatically on changes. And so it's putting all that together so that everything about your software is in version control. And that's really powerful because it allows you to make changes to the environments from version control. And so that means if your software, if your deployment process needs to spin up a testing environment for as it deploys code, you can change the configuration for that environment from version control. So there you can really do everything through your Git repo. Argo CD is one of the most popular tools for this. And it's actually really cool because there you're not actually deploying from Git, you're not deploying from version control to your environment. Argo CD is reaching out to your version control, just pulling for changes and taking those changes and deploying them. So it goes from you having to trigger a deploy to the deploy happening automatically. There are a lot of other good tools besides Argo. GitHub Actions is a popular one and integrates very closely with GitHub. Likewise, GitLab CI is good for doing test runners and making things happen, and it's integrated nicely with GitLab. Argo CD, especially if you're doing Kubernetes, is a great way to help orchestrate and deploy all of that. Circle CI and Jenkins are some of the classics. There are a whole lot of tools, and if you want, you can always, use Airflow to do deployments and things like that. But using tools that are built for it is pretty smart. Now, one thing to note is that you may work in a regulated environment or context where automatic deployments would be illegal or against standard best practices. And so in those cases, a fully automated deploy would actually be undesirable. So sometimes you do have to get sign-offs and not have things automatically flowing to production, but you can still use CI/CD practices for getting to the point where you can deploy and deliver software, start going through those approval steps and deployment processes. You can use CI/CD for that and should, even if the software itself ends up getting put on a DVD or physically inserted into an aircraft or something with a USB stick. Even if that's the deployment process, being able to start that whenever you want means that you're ready if there's an emergency or some urgent change needs to be made. You can still do that quickly and have confidence that it's not going to take you a month of integrating stuff to have a working build. So let's get to data pipelines. So one of the things to think about here is that data adds an extra dimension to CI/CD compared to traditional application development. And there's sort of three major dimensions there. One is code testing, making sure that the code functions as expected. The next one is data testing, making sure that the data transformation part of that code is happening in a way that makes sense. And then the automation side of automating a lot of this. So for data pipeline testing, there's sort of two aspects of correctness here. One, the functional correctness, does the code work? And then two, the logical correctness. Functional correctness is interesting because it's usually binary. It either works or it doesn't work. The pipeline, for an Airflow DAG, it either runs or it doesn't run to the most part. And this is relatively easy to test for with typical CI/CD testing approaches. So there are a lot of ways to test your code and make sure that it'll work. For the sort of data correctness, the logical correctness of the pipeline, that's harder to test for because it requires clarifying what you expect to happen from a sort of end-to-end data perspective. And oftentimes in a business setting, the expectations about what is happening might not be clear to everyone involved, might not be clear to you, and data tends to have hidden dependencies. And so your pipeline update may, a few days later result in someone discovering that numbers on an important dashboard have slightly changed and no one knows why. And that can be a real point of friction and confusion. So that logical correctness is the part that really sets data pipelines apart from typical CI/CD approaches. So, talking about code correctness. There are a lot of conventional approaches for applications, and those will work. Unit tests, you can use those for functions. A big thing that I would recommend for data pipelines is linters and formatters. SQL fluff, especially if you're not using that as part of your development and testing process, I would highly recommend that. It scans your SQL code within your IDE and really catches syntax and formatting errors. And the syntax errors would result in SQL code that is invalid and would not run. So just installing a simple linter in your IDE will allow you to reduce the whole sort of category of errors of writing SQL and deploying it, and then it doesn't work. So a couple of specific tools for testing pipelines around data quality. Data build tool has a testing model or testing module when you're defining your data models. So you can, as you say, like this is the table I want. You can also define tests for specific columns. Apache Spark also has a built-in testing utility if you're more on the sort of Spark data processing side, and you can use any of the Python libraries. Likewise, Python has a whole bunch of options for unit testing, PyTest, unit test, talks. There are a lot of good ones. So for actually testing the data itself, not just the pipeline, there are a couple of different interesting checks you can do. One is presence. Is the data actually there? Which you might think like, well, of course the data is there, or the pipeline will fail if it's not there. And you're usually correct. But if your pipeline isn't idempotent, you might get into situations where your pipeline tries to read data that isn't there and then still puts out some output. And if you haven't written it very defensively, when you rerun the pipeline once the data is there, the output, the empty output might already be there as a file. So you've got a pipeline that's picking up a file in S3, doing some processing, and then writing it back to S3. If you've written your pipeline a certain way, you could have a situation where the file isn't there and it tries to read it, but it doesn't fail and writes an empty output file. And then if there's already an output file there, it'll fail. So you can basically clog your pipeline if your data isn't there. So just checking for data can be a great way to make sure that the pipeline won't clog itself if you don't feed it anything. You can also check for data types. If you have primary keys, that's a great place to start. And you can assert that the primary key is not null. Hopefully you're using typed data formats like Parquet, where you can say, what data types you expect. Hopefully you're not doing strings for everything, but it is what it is. You can also check for uniqueness. Sometimes if you know that, again, for primary keys, if you know that everything should be unique, that is a great thing to test for to make sure that you don't accidentally have duplicates. If you know that there is a range of allowed values, you can check and see if the actual entries fit within those constraints, like phone numbers. If you know what the expected format for the phone number is, you can assert that it's the right length, that type of stuff. Enumerated values, that's a pretty easy thing to see, is the value within a set of values. One that can lead to some fun issues if you don't check for it is data freshness. If you have a pipeline that's set up to take the most recent file and process it, if that file doesn't arrive on time, but your pipeline runs anyways, it might reprocess data, and now you've got duplicates. So those are the approaches. And there's a question in the chat about, will the deck be available? And it will be available after the talk. So there are also some statistical methods you can use for data testing that get a little bit more nuanced, but I think are actually quite powerful. oftentimes in data, you as the data engineer, the pipeline builder, aren't responsible for the data quality issues. They're not your fault. They do become your problem, but they're not your fault. So if you have a data pipeline and someone upstream starts sending you a bunch of extra data, that could cause your pipeline to start having performance issues. If it's a huge amount of data, if your pipeline doesn't scale automatically, then you're going to have issues where it might get clogged because someone sent you too much data. Or just from a quality perspective, you may want to know if that data pipeline is processing data in a way that people will be interested in knowing about. And this sort of gets onto the edge of data observability, of really understanding what's going on with your data. But if you're looking at some of those statistics, like things like how many rows or how many gigabytes did a pipeline process, if you record those statistics, you can then use that as part of your tests. So you can look at it and say, if there is a increase in the number of rows compared to the 7-day rolling average for that, that could potentially help you catch some things, bugs that may get through and then cause wrong numbers to get displayed in dashboards, or otherwise making the downstream users quite unhappy. So let's talk about a few more specific tools for testing data specifically. There are some open source frameworks that are worth taking a look at. Great Expectations is one of the better ones. It does require a relatively verbose amount of specifying all the tests that you want. You do have to specify a lot of them out of the box, but if you want that quality, it's a framework for doing that. Soda Core is another data quality framework for SQL, Spark, and Pandas. There's a company around it that is investing a lot in the sort of open core version of their business. There is DQ, which is primarily for Spark, but also has a Python binding, and that's really designed as unit tests for data. And DataDiff is an open source library for looking at data differences, and so it's a really good way of looking at structured data and comparing it, which can be good to detect if there have been changes or not. So these are some of the tools that you could use as part of CICD testing for your data pipelines. So for automation, being able to deploy your pipelines automatically helps with your productivity and reduces the risks involved with manual deployments. If you've ever had to manually push pipeline code, that you got to be really optimistic that you're deploying it to the right environment, you're deploying the latest version of the code. I've heard all sorts of stories of people making changes to a pipeline and thinking that they're in dev, and then deleting a bunch of production data because they were actually in production and not in dev. So having automation helps reduce the risk that you accidentally fat finger something. One thing to note as we start transitioning into the challenges of CI/CD for data pipelines specifically is when we think about deploying a pipeline. I think a lot of us think about things like Airflow or Spark, Databricks. That is what we're referring to here. But some of that, when you think about a pipeline, if you're really thinking about the entire sort of value workstream from source data to final data product, a lot of that can happen manually as just SQL code in a BI tool or a data warehouse. And effectively, any changes there are a manual deployment. And so the whole sort of discipline of analytics engineering is the idea that you should take that section from sort of data warehouse to dashboard or data warehouse to machine learning model and make sure that all of that has an appropriate level of discipline and automation. So next, we'll be talking about the specific challenges of CI/CD for data pipelines, and this is the part that I think is most interesting. An important point, and I know I said this at the start, but I'm going to say it again, data pipelines are not software applications. So a data pipeline is different, and I'm going to give you a couple of reasons of how they're different. First is that the feedback cycles are longer. It takes more time to see if a change to a data pipeline resulted in defects and failures. Data also has mass, which changes sort of how you think about the process for moving code and artifacts around. The large number of vendors in data, especially in, I'd say, a sort of modern data stack corporate environment, can result in a lot of challenges for CI/CD. There's also, I think, a less clear distinction between discovery and deployment, where the feedback cycle or the process of understanding what you're building from a pipeline perspective may evolve very rapidly. I think there's also more siloed development for data pipelines compared to software applications. And this last difference, which I think is more of my personal opinion or really an open question, is that there isn't a build process in the same way that you would have with a software application. I'll elaborate on that in a little bit. So first, feedback cycles are longer. So when you have a web application or an API, the piece of work is fairly small. Like if you have an API, you have an API request, and hopefully that gets resolved in a couple of milliseconds, less than 100 milliseconds. So when you deploy, if you update an API and deploy that and start sending traffic to it, you're going to very quickly get feedback. And if you deploy the new API, you'll see that you get errors or you don't get errors, and you can have high confidence in minutes that your change was successful or a failure. For a data pipeline, that you don't get that. If you have a pipeline that takes hours and you run it once a day at 2 a.m., if you deploy something, you don't want to run it early. So you have to wait and see the next morning, is it going to fail? So you're reducing yourself to one feedback cycle a day instead of something that can take minutes. So that's the happy cases. It works in dev and then fails the first time in production. You also can get places with that logical correctness, again, data correctness that I mentioned earlier. If that's the part that is wrong but doesn't get caught, it may take a human several days to notice something different in a dashboard. And so if you make a change, if I make a change today to a data pipeline, I might hear about that next week. And so the feedback cycle is just a lot longer. And that also makes a lot of practices for automatic deployments and safer deployments, like blueprint deployments and canary deployments. Those become much less tractable for a sort of typical data warehouse, data pipeline, because you don't have the tools to do that type of deployment, but also you'd have to wait days or weeks to see if your change was successful or not. And that makes it harder to get value from CI/CD for data pipelines. So second thing is that data has mass. With application development, the thing you're delivering is an application. That's the artifact. You put something in a Docker container, deploy it, you're good to go. For data pipeline, you're deploying the pipeline onto something that's already deployed, which is then integrating and reaching out to other systems. So it's not as standalone as those changes for an application. And those volumes of data, that's heavy and stateful. And a lot of CI/CD tools, the less state you have, the better they work. So, if you have an API, you can test that API interface in isolation in a meaningful way. With a data pipeline, it's much harder to usefully do that kind of testing. Those tests are harder and they're more expensive with large data. If you actually do a good job of maintaining environments that are production-like, if you actually have the same size of data, which is important for data pipeline performance, that's expensive. So if say you have a dev, QA, and prod environment, if those all have copies of your production data, that's going to be 3 times the data storage, which if your data is small, that's fine. But as the data gets larger, that might be really expensive. And for a data pipeline, sometimes you have enough compute, performance is no problem, but oftentimes you'll have some subset of data in dev or synthetic data, sample data, test data, et cetera. And that's going to be really small compared to the size of production data. So you won't actually have as much confidence that your changes will work in production because the dev environment just doesn't have the same data. You also get fun things where the applications become commingled with data, and that makes it harder to test that code in isolation. Because you could like do mocks for unit integration tests with your pipeline, but that wouldn't really be useful or representative. And so again, that makes it harder to get value from conventional CI/CD tools and approaches. So the larger number of third-party tools that I mentioned. With data engineering, you get build versus buy decisions, and in my opinion, they're often heavily tilted towards buy. Unless you have a use case where you know what you want, and you've got some great people like Anant Corporation to build something cool for you, you often just should buy it yourself. Go to Google, go to Amazon, give Snowflake a bunch of money. Like that's the smarter way than trying to run most things yourself. And compared to for the value you get compared to the cost, it makes a lot more sense most of the time compared to trying to run it all yourself. The problem there from a CI/CD perspective is now you can't actually control the infrastructure as much, and some of these SaaS vendors are not enthusiastic about offering great APIs for allowing you to test things and spin things up well. So that can make it harder to have a good testing setup. So, you also have to write more integrations, sort of more surface area to deal with. So it takes more work to get value from CI/CD with all of these third-party tools. Though you may be operating in an environment where you don't actually have all of these, in which case conventional methods might work very well without additional effort. But I think for a sort of data warehousing focused data engineering environment, it does take more work to get that value. So another issue is that there isn't a lot of tooling for doing good CI/CD for data. And the sort of immaturity of the tooling, and I think we're probably about a decade behind application development for CI/CD tooling and just DevOps processes for data in general. So the tools need improvements, and there are a lot of different vendors and a lot of different open source tools, which makes it harder to get everything to fit together and automate those deployments. And that really increases the cost of building good tests and CI/CD. You can still get a lot of value out of it, but the cost to benefit, the return on investment is probably not going to be as good as it is with conventional application development. So there's also, I think, a lack of clean software development lifecycle separation from exploratory data analysis. And you don't really know when you're getting out of discovery into development. If your goal is to build data pipelines for a machine learning model, or help keep business intelligence teams' dashboards fed. Sometimes you'll get very clear requirements about what they want, but a lot of the time, the data analysts or data scientists, they're figuring it out as they go, trying to discover ways to make the data more useful. And that means that you don't know exactly what you're going to be building, and that might change fairly quickly. And I think there are a lot of benefits. Well, this whole talk is about the benefits of CI/CD, having automation and testing. Those do have cost. And if you have some stability or want long-term stability, like the investment into the test and automation is 100% worth it. But the more you're changing things, the shorter the time you'll have to get value from any specific test or automation is. So if you're changing things a lot, like you might while sort of doing earlier discovery and prototyping, you're not going to necessarily get the same amount of value. So it makes it harder to get that value and harder to commit to investing in that testing and automation. Also, for that lack of ownership, where you may be working with data scientists, data analysts, it can be unclear about who actually owns which parts of what. Is your data pipeline also responsible for updating a dashboard, or where are those interfaces? And that can make it even harder to invest if you want to invest in CI/CD for something that you don't own, especially in a corporate setting where ownership is desired strongly. So for data pipeline development, I do think this tends to happen in silos a little bit more so than with application development. And so I think that there's a little bit less collaboration for the actual code changes, but also more collaboration for the data flows. So for the process of making a pipeline that's valuable, I think there's a lot of collaboration that goes into that, working with different stakeholders for upstream teams, downstream teams, et cetera. But for actually making the code changes, I believe that the typical data engineering team is working on more separate things than a similar software application team. So there's less opportunities to step on each other's toes. And so that means that writing useful tests and dealing with that, it's going to be harder. So you have to spend more work writing tests if you're going to actually get value out of them. So the last point I want to make about data being challenging, or CI/CD for data pipelines having challenges compared to traditional application development, and this is really my opinion and a question. So if you agree with this or disagree with this, I'd love to see that in the chat, because I'm still sort of thinking about this. But a lot of CI/CD, a lot of the literature out there focuses on the concept of having a build. You build your software and then deploy it. When it comes to data, I don't think that makes sense. I don't think that exists. And you don't have a single artifact that gets deployed most of the time. And so you have a sort of interesting thing where the valuable thing you do is having a production system, which is true for software as well, usually. But making changes to those is not as discrete. It's a lot messier, I think, than most application development. Really, everything you do sort of is a database migration all the time. And it's interesting because you have different parts of it that can be stored together and run together, but fail separately in a way which I don't hear about that happening to the same extent with most software. So there's a certain thoughtfulness that I think is required with data that's effectively like developing in production, or hot fixing in production for a typical web application, which is not a place that I think we want to be in as an industry, but the tooling is not to the point yet where I think we're able to make that work. So really, like, it's harder to use these techniques for data pipelines. And we've got work to do as an industry to make that better, but I think that's sort of the state of where we are. That said, I have 2 takeaways. One of which is that even though it's harder, you should still be doing it, or at least doing some of it, especially around some of the basic testing and development hygiene with Git and a little bit of automation. That can save you a lot of trouble without too much pain. The second thing is think for yourselves. Again, a lot of the literature and techniques out there for CI/CD for web applications, the cost and benefits are different for data pipelines. And the goal is to develop better software with less time and stress. So keep that in mind when looking at some of these tools and approaches. And with that, I saw that there were a few questions in the chat. Feel free to add some more. Let's see. All right. We've got a couple. I'm going to go in reverse order. Are there further implications of the phrase data has mass? What else does that phrase mean to you? That's a good question. For me, the thing to remember there is, data has mass, and that means that things tend to move around it. Even if you don't want that to be the case, if you have data, things gravitate towards that because of its mass, and that changes how people end up building solutions around large volumes of data. Some of that is ergonomic. It's more comfortable to do things closer to the data because you don't have to spend as much time controlling how it moves around. The best data pipeline is one you don't have to build. There's, in addition to the ergonomics, there's also the economics. If you're on one of the major cloud providers, it gets really expensive to pull data out and pay those egress costs before processing it and pushing it back in. So keeping things close to the data is very economic most of the time. We also had a question very early on about how do you do a CI/CD data pipeline in real time and ensure that you do not break any data integrity or corrupt data in any way when you could have millions of rows. So that's a good question as well. If you're doing stream processing or other kinds of large-scale data processing, where you may have a lot of sort of different nodes or workers processing data as it comes in, and you may actually be able to use some of those conventional CI/CD approaches like blue-green deployments or canary deployments, where you can slowly roll out changes to a data processing pipeline. Where because if you think about like what does a sort of typical web server API look like? You make an API call to it, it does something and gives you a response. Fundamentally, data, the only difference is one of scale, in terms of volume and velocity, where you just use a regular API for data processing if you want. So there's conventional techniques may work, but also just more testing and focusing on what it means for you to have your pipelines work correctly when you have that kind of scale. Any other questions? And feel free to reach out to me on LinkedIn, Twitter, email, etc. Happy to answer questions and talk about this stuff more.
Will, thank you so much for being here. It looks like there's maybe one other question. I think you largely answered it during the session. How do you think CI/CD practices for data pipelines differ from code?
Yeah, another good question. So I think one of the big changes or sort of big differences is the distribution of test types. I think is slightly different. And I didn't get into this in too much detail, but there's sort of different levels of scope for testing code. We sort of go from very detailed unit tests, like you're testing each specific tiny unit of software, through larger integration and eventually end-to-end tests where you're going from testing each individual detail of your software up to, does the software sort of end-to-end work? And I think that data pipelines have a lot less in the middle compared to regular application code. Because with a lot of data pipelines, some of them have a lot of processing, and there's a lot of stuff in sort of intermediate that you'd want to test. But in a lot of cases, the hard things with data pipelines is either the very sort of low-level logic of, if I do this transformation or run this function on a column, will it work correctly? Like, does the algorithm work? So you get a lot of unit testing, I think. And then on the full end, you want to know, will this pipeline run end to end? Let's do a sort of end-to-end test. But I think in the middle, there are a lot of places where the value or the cost of writing like integration tests to test whole modules, again, I think for more sort of data processing, data warehousing, data lakes, I don't think that there's as much value there compared to the cost. So I think you get a lot less of that in data pipelines than you do in software. Though there's still value. It's just more work, so the return on investment is lower.
Okay, that is the last question that was in the chat. Thank you so much for being here. I will be posting the slides in the YouTube description after the end of the session. And again, thank you everyone for being here. Thank you, Will. And we do have Data Engineers Lunch scheduled for next week. And we look forward to seeing you then. Thanks so much.
Take care, all.
Okay, the